This is Precalculus Concept 21D. We're going to talk about solving log equations in a different way. Just like when you have exponents, an equation with exponents that have the common base, we can basically look at just the exponent part of it. The logarithms have that same kind of property, so the key concept here is that log base b of one thing m, if that equals log base b of another thing n, then hopefully it logically follows that m must be the same as n. Okay, this is called the one-to-one property, and it's one of the ways for solving an equation with a logarithm in it. 4 steps that you want to keep in mind when solving with this process. Step number 1, very important if you're going to do this, that you have a simple logarithmic equation on the left and a simple logarithmic equation on the right. So your job, for most important job in these problems, is to simplify both sides of the logarithm so that you have single logs with no coefficients. Once you have that, then basically you can ignore the logs and set the inside part of the first one equal to the inside part of the second one. You're going to solve, and as with our other examples, you're going to check your answer. Very important you do that when solving a logarithm because you may get extraneous solutions. Alright, let's look at an example. This is a fairly complicated looking logarithmic equation. Before or when I start, I want to think about getting single logarithms. So let's look at the right side first because we actually already have a single log, and that's a good thing to have. On the left hand side though, I do not have a single log. I have 2 logs that are being subtracted, but I have a property to deal with that, and so I can change this to the division log of the quotient of the 2 expressions, right? That's one of our properties we studied in a previous lesson. So now that I have a single log on the left and a single log on the right, I can just look at the inside part. So I have this expression next. And now I have kind of an algebra 2 type question where I have to solve. A lot of times cross multiplication is going to be a good way to go. So when I do that, I get x squared plus 2x. And that's going to equal 4x plus 3. And this ends up being a quadratic. Remember, we want to set our quadratics equal to 0, so I'm going to actually have a minus 2x minus 3 here. And most of the time you should be able to factor these, so I get x minus 3 and x plus 1, and 2 solutions of 3 and negative 1. Okay, again, I want to make sure at the very end here I do a check. I do my check here in orange. So my check for this problem would involve making sure that the solutions I got both work in the original equation. So if I go back and plug in a 3 to the original equation, I would get log of 5 minus log of, plugging 3 in there is going to give me 4 times 3 plus 3, which is 15. And on the right side of the equation, I would have log of 1/3, right? 1/3, plugging in 3. And you could either punch these in on your calculator, see if those in fact are equal, or you could again use your properties and realize that this is really log of 5/15 when you condense it. And log of 5/15 and log of 1/3 is in fact the same thing. So this one checks. I'm going to circle x equals 3 as definitely a solution. When I try negative 1, here's what I'm going to get. Log of 1 minus log of negative 4 plus 3 is negative 1. And over on the right side, I'm going to have log of negative 1. So even just in thinking about this or writing it out, I've got some problems because I can't take the log of a negative number. This whole check doesn't even work out, and this is an extraneous solution. So my only solution for this one, x equals 3. Alright, let's try another example here. This time I have a single logarithm on the left side and 2 logarithms on the right side that I can combine into a single log. 7x minus 23 over x plus 1. And my one-to-one property says that x minus 3 must be equal to 7x minus 23 over x plus 1. Cross multiplying here gives me a quadratic x squared minus 2x minus 3 and 7x minus 23. Again, I have to solve a quadratic by moving everything to one side. Subtracting 7x is going to give me a minus 9x, and adding 23 is going to give me a plus 20. And this is also something that factors pretty easily. I get x minus 4 and x minus 5. Okay, solutions. Initial solutions are x equals 4 and x equals 5. And then once again I have to go back into the original expression, whoops, excuse me, and plug this in. So when I plug in 4, there's no issues in the first expression. The second logarithm would be log of 28 minus 23, so that'd be log of 5. And the last one's going to be log of 5, so that one's going to check. There's no domain issues. When I plug in 5, I'll get log of 2 there, I'll get log of 12 there, and I'll get log of 6 there. So this is a case where you get two solutions and they both work. And just keep in mind that sometimes they both will work. Sometimes one will work, one wasn't, and there's actually cases where neither will work. Alright, next one is you try. Take a look at this and see if you can solve for x. Okay, should have gotten 11/3 as a solution, and it's a solution that checks. The work is here. I need to condense both sides of the logarithm, of the expression, so I get a single log on each side. The one-to-one property says that I can remove those logs now. Cross multiplying gives me a quadratic equation. The x squareds actually cancel, so it actually ends up being a linear equation with just one solution. And 11/3, which is about 3 1/3, will actually work in all 4 of the logarithms at the beginning, so there's no undefined or problem situations, and so 11/3 is your final solution.